exponents. And a little subheading, the laws of exponents. And it would behoove you, whatever that means, to listen carefully, because this is one of those things where it's very easy, but it's also very confusing. One of those things where math is not hard, it's just confusing. That is today. And here is what we're looking at. Okay? The first thing, if you are multiplying, let's say I have x to the third power times x to the fifth power. And I am simplifying that, I am combining that. What do I get? Well, here I want you to look at this. X to the third power means you have x times x times x. X to the fifth power means you're taking 5 more x's times them. What's that? 1. So if you multiply x to the third times x to the fifth, you end up, Faith, with how many x's? 1, 2, 3, 4, 5, 6, 7, 8.
5 plus 3,
X to the 8. Which confuses people because they see this as multiplying and then they multiply those exponents together, and a lot of people put x to the 15th. That is not how it works. So the first rule in laws of exponents is when you multiply like bases together, you, and here's the big point, add exponents. Add them. When you multiply, you add. It confuses people, but that's the way it is. If you think about it like this, it usually makes more sense. Now, please understand, it's only when they're like bases. If I have x to the third power times y to the fifth power, you can do nothing with that. They're not like bases. It's that is its simplest form. You don't write xy to the 8th power, because that would just mean you have x and then y to the 8th power. Okay, it's only when you have like bases. It's a little like this. If I had numbers, 7 to the 2nd power times 7 to the 3rd power is 7 to the 5th power. They might ask you to do that out. Like bases, when you multiply them together, you add their exponents together. Now, what about when you divide? What if I have, let's go to the new board. What if I have x to the 10th power over x to the 6th power? Well, ladies and gentlemen, again, you don't have to do this, but this is what you should be thinking. This is the concept behind it. You have 10 x's on top, 5, 6, 7, 8, 9, 10. You have 6 x's on bottom. What happens when you have like factors on top and on bottom? They cross off 1 for 1. What are you left with? X to the 4th. Can anybody tell me what my law then is when you have like bases divided by like bases? What did I do with 10 and 6 to get 4, Carter A?
When you divide like bases together, you subtract exponents.
Exactly. When you divide like bases, comma, you subtract exponents. Another case in point is this. 3 to the 6th power over 3 to the 3rd power would give me, Parker, let me review. When you divide like bases, you subtract exponents.
That would be 3 to the 3rd?
exactly, 3 to the third power, 6 minus 3 is 3. Which they might ask you to do out, which is 27, don't say it's 9, but if they ask you to do it all the way out, you can do that. You can't change x to the 4th, that would be it. Abram, you're gonna answer the question I didn't ask yet? One more law of exponents, which will completely thrill and astonish your friends. One more thing, if I have x to the 5th power to a power.
What?
Something with an exponent to a power to a power. Now, if you break this down, it's really not that hard because it looks like this. Okay. This third power tells me I have 3 of these multiplied together, which means I have x to the 5th times x to the 5th times x to the 5th, which goes back to our other rules of exponents. If you want, you could write all those out. X to the 5th times x to the 5th times x to the 5th. What do I get when I have x to the 5th power to the 3rd power, an exponent to an exponent? Brant?
X
To the
15th power.
15th power. Anybody tell me the law of exponents to exponents? Abram?
The law of division.
No. I don't know what that even means. If, here's how I'm going to start it. If you have an exponent to an exponent, you shouldn't have to write it all out like I just did there. You should be able to come up with one simple little thought, and that is, way to Davis, you?
You multiply exponents.
Yes, you multiply exponents. So if I have b to the 3rd power to the 3rd power, b to the 3rd power to the 3rd power is Jacob Licht.
B to the 9th power.
B to the 9th. It's hit to b squared. Okay, so let's tie it all together here. I probably should look at what the book gives us here. Here we go. X to the 5th times x to the 2nd power equals x to what power? X to the 5th times x to the 2nd, Carter Westfall?
Equals x to the 10th power.
It is not x to the 10th power. Carter, you just did this, x to the 5th power squared. You just did an exponent to an exponent. This is not, this is two bases the same. X to the Amelia? 7th power. This is x to the 10th power. Exponents to exponents, this is two bases, but yeah, that's why I said it's not hard, because it's really not hard to add 5 and 2 or multiply 5 and 2, it's just hard to remember which case you get it. How about this one? X to the 5th divided by x to the 2nd power is x to the, Parker?
3rd power.
3rd power, because exponents divided by exponents get subtracted. How about this one? 10 to the 6th power over 10 to the 2nd power. Carolyn is 10 to the 4th power. What is 10 to the 4th power, just so we know that? It's really easy to do. It is, you don't have to actually sit down and multiply all those 10s together because it's simply what, Brant?
400.
10 to the 4th power. Evelyn?
10,000.
It is a 1 with 4 zeros after it. 1, 2, 3, 4. 10 to the 4th power is 10,000. Another one right out of the book. 2 to the 5th power squared. 2 to the 5th power squared. Two to the 5th power squared, Tyler, is?
2 to the 10th power.
And what is 2 to the 10th power? By the way, this is called exponential growth. You have a little number too, but when you get it to the 10th power, it gets awful big. It's not super big, but if you have 10 2's multiplied together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 times 2 is 4, 8, 16, 32, 64, 128, 256, 1024, 2048. Exponential growth means this. Starts out slow. I mean, 4 and 8 are not big numbers. 16 is not a big number. 32 is getting a little bigger. 64, once you get here, what would be 10 to the 11th power? Multiply that by 2, you get 4,096. What would be 2 to the 12th power? Double that, you get 8,192. 2 to the 13th power? 16,384. 2 to the 14th power? Notice how much bigger it keeps getting. I mean, as you get farther, I mean, this is going to double that. What's that? 32,768. 2 to the 15th power? 65,000. What is it? 536.
I'd be rich.
I'm not 100% sure.
So we'd be rich.
I think it is. It's not hard to double numbers.
Mr. Hahn, remember when you talked about if you had like a penny a day and you kept on doubling it,
Yeah.
you'd get like $1 million?
That would be 2 to the 30th power, by the way.
Oh my God.
Well,
Like
actually,
30 days
yes, it'd be
ago,
2 to the
you
29th power. That's the second one. You can't. So,
2 cents.
the next one is what? 131,072. It's not hard to multiply by 2 in your head. Alright, for tomorrow, I got a quiz for you.